All right, so now we know three ways to solve systems of equations. We can graph them, we can use substitution, or we can use elimination. Well, now, of course, the next place is how do we see these in the real world? So we are going to do some modeling today. Here we have Samantha and her friend Craig, and they went to a concession stand. We're going to do Samantha in white. Samantha bought 3 pretzels and 4 sodas. Kind of easy. 3 pretzels and 4 sodas. She paid a total of $11.25. So that equals $11.25. Craig, on the other hand, we'll do him in yellow, went to the same stand, so that means they're the same set price. He bought 5 pretzels and 2 sodas. So here is he buying 5 pretzels and 2 sodas, and he paid a whopping $8.25. So there's my system. We want to find the price of each item. For the most part, elimination is always the method you're going to use to solve systems of equations. So, by elimination, we want to get additive inverses of one of the variables. So by looking here, I could choose variable P or S, and I'm going to go for S because it's very easy for me to simply multiply this bottom equation by -2, and I will have a cancellation. So now I'm going to rewrite. Get this out of the way so I have some room. I didn't affect the first equation, so that stays the same. But the second equation, I multiplied everybody by -2. And now I will eliminate because I can add these equations together. Lovely. The S, the soda, cancels out. I'm left with -7p equals let's see, that's 25 cents, -$5. Oops, I already have the negative sign there. -$5.25. Little division by -7 tells me each pretzel costs 75 cents. Okay, I'm halfway there. Now I've got to go back and find out how much one soda costs. So that means I'm going to go back and substitute into either equation. It doesn't matter. So I'm going to substitute into, I need to get myself a little more working room here. I'm going to substitute in, to the first equation. That was interesting. 3 times 0.75 plus 4s gets me $11.25. Well, 3 times 75 is $2.25. Move the $2.25 over. 4s equals, let's see, that's 9. And then we know our quick way to divide by 4 is to take half twice. So half of 9 is $4.50. Half of $4.50 is $2.25. So there we have it. One pretzel costs 75 cents, and one soda costs $2.25. Now we can check ourselves, and I'm going to use a graphing calculator. All right, so for the first one, 3 times 0.75, because that's how much a pretzel cost, plus 4 times $2.25, better get me $11.25. It does. All right, for the next one, 5 pretzels, so that's 5 times 0.75, plus 2 times 2.25 for a soda, better get me $8.25. Good, it all checks. Now, we have an interesting problem here. I don't care how you solve a math problem as long as you solve it using correct math. So for example here, if I start to read this, let me get my shape. It says a rectangle. So I'm going to draw my rectangle. Has a perimeter of 204 feet. So I'm going to bring that out over here. Perimeter equals 204. Don't know how I'm going to use it, but I know I am. Its length is 6 feet longer than twice its width. Its length is 6 feet longer than twice its width. So I don't know its width, but I know its length is 6 feet more than twice its width. Now, if L stands for the length of the rectangle and W stands for its width, write a system of equations that models this information. See, here, this question wanted me to use 2 different variables, L for length and W for width. They wanted you to practice writing 2 equations. So they wanted something like 2 lengths plus 2 W's would get you the perimeter. And then they wanted you to compare the length and the width, saying that one is 6 more than the other, and you get another system of equation. But actually, that's making it too hard. The point of the matter is, can you solve it? You see right here, I come up with 1 equation if I do it this way. Because we know now we only have 1 variable, W, so therefore we only need 1 equation. When we have 2 different variables, that's why we need 2 equations. So why are we going to make our life harder? I did this problem on purpose because I wanted to point this out, that we don't need to complicate it, that we can solve it. We understand that 2 widths plus 2 lengths will get us our perimeter. So let's not complicate things. Again, as long as you can solve it and it's mathematically sound, I will take anything as an answer. So 2W plus 12 plus 4W equals 204. This gives me 6 W's on this side. I'm going to bring the 12 over here. So let's see, 204, 200 minus 8 is 192. Divide that by 6. And we get the width is 32, but we're not done because it said find the length and the width. So now, to find the length, I simply double my width, that's 64, plus 6 more is 70. I indeed can add this up, and it will equal 204. All right, last one, number 3. We got Jonathan. He has 9 bills in his wallet. All right, there is a big fact right there. He's got 9 bills in his wallet. So over here, I'm going to pull out the number 9 because it's important. They are all either $5 bills or $10 bills. All right. So we know that if we take the number of $5 bills and add onto it the number of $10 bills, it will get 9 bills altogether. That's the amount. Actually, I won't say amount. I'm going to say that's the count. The next line is the worth, because he's got a total of $55. So that means every $5 bill is worth $5, and every $10 bill is worth $10. And if we counted up the worth of these bills, it would total 55. This one's actually one of the harder problems for kids to understand. They always get the worth line, but they don't get the count line quite easily. I'm just counting up how many bills are in my pocket. And then we put a monetary value on them to see how much moolah I got, so when I go shopping. So once again, which method are you going to use? Well, I'm going to use the elimination method. I'm going to multiply everybody by, let's see. I'm going to multiply this one up here by -5, because I'm opting to have my f's cancel out. So -5f minus 5t would get me -45. On the bottom here, this second equation didn't change. And now I can add them together. Those cancel out. This would leave me with a lovely 5t. And 55 minus 45 is a lovely 10. So Jonathan had 2 $10 bills in his pocket. If I go back to my original statement of him having a total of 9 bills in his pocket, then the $5 bills, he must have had 7. If I do this and figure out its worth, well, 2 10s are 20. 7 5s are 35. So he has a total of $55. Everything checks out. And now just to make things a little clearer, when I would write my answer, I would write it so that everybody can understand it. So I would say, better to say $10 bills equals 2, and $5 bills equals 7. All right, have a good holiday. See you in 2 weeks.